So let me introduce myself. My name is Rani Richardson. I work for Dassault Systems. I'm the director of an aerospace and defense technical team, and we focus mostly on business transformation, but there's a lot of good additive in there. And this afternoon in our panel session, we're going to talk about aerospace additive manufacturing and the journey that we take from design to manufacturability. And more specifically, we're going to focus on the future of additive manufacturing and maybe talk about like robots and material science and things like that. But before I get started, I have to do my company community service and mention that we're a platinum sponsor of the conference. So we are participating in the scavenger hunt that you heard about today. And we are giving away a phone, soap, charger, and it's a sanitizer as well. So please make sure you participate in the scavenger hunt. So I would like our panelists to introduce ourselves. So Jessica, would you like to start off and just tell us a little bit about yourself? We know you work for Dassault Systems also, but what you do at work and what made you want to become involved in additive?
I do. Jessica Kinman. I've been here about 4 years. I run our aerospace and defense industry from a industry segment perspective, so covering and working directly with our customers and helping with kind of that innovative idea of where are we going next and helping the customers get on the right track with going forward with that. I kind of fell into additive. I've been in the A&D industry, God, like over 15 years now, and then additive came on. I previously worked at Boeing, and they started playing around with it, so that was kind of my first dipping my toe into additive on where they were going to do it and how they were going to do it, and now I actually run that process from our company's perspective. So.
Okay, all right, thank you, Laura. Laura, you're on mute.
Yes, thank you. Thank you for having me today here. I hope you hear me well because my headphones didn't work out, but yes. So I'm Laura Cordova. I am from the University of Twente, also working at the Fraunhofer that is also located at the University of Twente. We have several initiatives in additive, in particular in metal AM. How did I start getting involved in this? It was back in 2015 when I started my PhD at the university where I focus in metal AM. So I've been working with laser powder fusion with multiple materials, for example, titanium, Inconel, and different aluminum alloys since then. Back when I did my undergraduate study, I already touched some of the powder metallurgy techniques. So I was very curious with this kind of powder production methods. So that's where it comes from.
Okay, thank you. And Rachel.
Hi, Rani, thanks. So my name is Rachel Fu, and I also work at Dassault Systems, but I actually work in the simulation brand, and I work in our R&D group as a portfolio technical director. So we kind of manage a team that's looking at kind of strategic initiatives. So, what emerging technologies could benefit from simulation, or, where should our simulation technology be kind of headed? And so that's what my team does. I was kind of drawn to additive about 4 years ago. I think there's a few different reasons. So I was, kind of personally at that point in my career where I, wanted to learn something completely new. So you want to do that, kind of steep learning curve piece, and additive, obviously was a really good opportunity for that. And then secondly, it's a really complex technology, and I'm really kind of drawn there because it, requires all types of engineers and material scientists to collaborate for it to really be successful.
Yeah, those are great stories. I was drawn to it also. I started working with it a few years ago, and then at Dassault Systems, when we started working on it, I knew it was something that I wanted to work with, and I'm glad because it's such an evolving industry and it's fun, and I get to work with all of you, so that makes it even more fun. So I'd just like to move on to the first questions because we have an abbreviated time, so I'm hoping that we'll get to all of them. So if you could just keep your answers just a little bit abbreviated so that we can get to all the questions. But Laura, starting with you, I'm thinking the future, keeping that in mind. So why do you think aerospace and defense is really at the forefront of additive manufacturing technology, paving the way for all the other industries?
Yes, I think, well, aerospace industry is a very exciting and very fast-paced development industry. So I think this industry is also pushed to the limits. So its challenges constantly. The last 15 years, we have seen a double of the commercial flights increasing. So there is requirement to reduce cost, reduce the fuel consumption, and also especially sustainability nowadays. So I think additive perfectly fits in those requirements for weight reduction, for product design, and well, in many ways it fits. So I think this industry has taken the lead, even though it's a quite heavily regulated industry and quite challenging in terms of certification, but it's showing us the path in many of the technologies. And I can speak on the behalf of metal, which is quite advanced in comparison to other industries.
All right, thank you. Rachel, would you like to add some comments?
Yeah. So I've been working in aerospace for about 10 years now. So not quite as long as Jessica, but I also spent about 5 of those years kind of as a consultant at Boeing, kind of looking at composite simulation. And the time I was there was when they were having kind of the 87 Dreamliner crisis, so kind of all these expensive delays that were in the news, and that was the project I was working on. But I really feel like through that experience, I've kind of seen, firsthand how, kind of these high engineering standards. So, Laura mentioned, some of the regulation, the certification are constraints. I actually think it's really the certification that drives these high standards, and that's kind of what's forcing the A&D industry to actually use the most advanced engineering tools because they have to meet these requirements. And so A&D is really kind of advancing additive in terms of if you listen to Dr. Orm's presentation, this idea of repeatability and process control and traceability. And so in the A&D industry is kind of forcing this evolution of additive from being kind of this grassroots maker movement to be, this rigorous and standardized manufacturing process, which, really does come from a lot of these, regulation requirements. And so I think, because, the A&D industry is able to bring it to this, kind of level of rigor, other industries are going to be able to benefit from, kind of the advancements that happen here.
Oh, those are good points. Thanks. Jessica, do you want to add anything?
Yeah, I always joke about aerospace being fat and happy because our profit margins are very high compared to some industries. So we put a lot of effort into our research and development. So we're kind of that forefront that gets to play with everything up front. And once we kind of get the process going, the other industries kind of hop on. We also have a lot of use cases. Looking into space, you have limited resources when you're on a space station. So by having that 3D and being able to print stuff, the same thing on our defense sector. When we send field ops and we have military out in a desert, they don't have access to any type of tool shop, or they don't have a supply chain that can always come in. So when you look at those other segments, there is a need to provide some of those inventories, some of those spare parts, and additive just kind of hits the mark there. Also in space, think about 1 pound is what, $10,000 to get up. There's that big cost savings that both Laura and Rachel talked about, that lightening it up for space and saving money there too.
That's good points. Thank you. So Jessica, starting with you, we've all heard the, design anywhere, build anywhere. How does this relate to additive manufacturing?
To the point I just talked about, the defense and space, I've worked with some recent customers who are looking for ways to simplify their spare part inventory. It costs money having parts sitting there on their shelf. So by moving over to kind of a print solution, that does allow them to print anywhere, print what needed, print on demand. I recently had conversations with the military about their NIS system where we have a common part across different countries. And if you could kind of think about that, and instead of having the part available to where you ship it everywhere, what if you just pull that common number, print it off on your, in your shop there, and you have that available? You're simplifying the supply chain, you're simplifying transportation costs. There's just a lot of advantages there for that.
Okay, all right, thank you. Laura, do you want to add any comments to that?
No, I think it's all covered. In fact, I agree very heavily with Jessica that this is also from the sustainability point of view and decentralized supply chains. And we hear well, very recently a lot about digital inventories and resource management, that this is the way, and having the possibility to produce on demand, especially now with a lot of personalization of products that we have heard in previous presentations. This is very important to reduce all the tooling, all the molds that are requiring other more conventional manufacturing techniques. So I completely agree that this is one of the most important benefits of AM.
Okay, great, thank you. Before I get to the next question, I should have mentioned at the beginning to the participants that are watching, if you do have any questions for us, put them in the chat. We'll try to get to a couple of them at the end. I should have mentioned that at the beginning, so I apologize. So, because we did leave some time for open Q&A. So for the third question, Rachel, starting with you, as an industry, how are we overcoming the challenges when it comes to material certification?
Yeah, so that's a very good question. So, so I think the aerospace and defense industry is really kind of trying to tackle a lot of these tough questions around material certification, which also relates to, part quality, which we know is an issue for additive parts. And that's tied to this idea of, process repeatability. How do we make sure that, we get the same quality of part from, machines that are in different countries or things like this. And so one of the ways this is being done is really kind of using, what I would say are kind of the most advanced simulation capabilities that are available. So when we think about part quality, we know it's a very difficult topic for metallic parts. We've seen it kind of come up in the presentations today, and it's difficult because really during the build, every single point in the part is actually experiencing a very different thermal history during the build process. And that's related to, your process parameters. It's also related to part geometry and things like that. So there's really a lot of kind of potential that, different regions in the part might have different microstructure. And that, gives you kind of this wildly different part quality that might happen. So I would say the industry is really kind of at the forefront of using advanced simulation, because what this, kind of type of simulation lets you do is you track all of the thermal gradients. You can predict what those temperatures are going to be during the build. And then once you have those gradients, you can also predict how your microstructure is going to evolve. You can track all of the phase transformations. And that really gives you a lot of control over your part quality and your material certification. And so actually, Amy talked this morning from Oak Ridge National Lab. So she had a very good explanation of, microstructure and how they are using, they're actually, controlling the energy supplied to the process in order to dictate this microstructure. And so I think this is, a really key area in how do we make sure we have, high quality parts? How do we have these certifiable materials, certifiable processes?
Okay. All right, thank you. Laura, from a research perspective, do you have anything to add to that?
Yes, no, I totally agree on the part of the quality assurance, the monitoring of the process. From the metal point of view, we work both with powder and with wire. So I can talk mainly about the powder because that's where I specialized. And when we create metal powders, we have to make sure that the powder from the supplier comes with the quality that is expected, but also that the powder doesn't degrade throughout the process. And we call that reuse. And the powder can be rejuvenated and you can restore some of the properties. But what has been a challenge is that AM has been growing so fast that most of the standards and most of the quality, let's say, certifications are based mainly on conventional manufacturing. And in this case, for powder metallurgy technologies like MIM or present sintering, where also powder is used. But in AM, we have different specifications and different requirements. So for example, properties such as particle size distribution and chemical composition and morphology of the particles are important to keep in mind, that these are the feedstock that we are using, the base material. So basically, if the powder is damaged, contaminated, this will be inside the parts that we are producing. So in the point of view of material, this is a challenge still, especially in terms of traceability, how to trace all the changes that is happening in the powder bed, all the sputtering of the welding process or kind of welding process that we have. And I think this is one of the main challenges currently for aerospace certification in terms of material. So that's where I can talk about. And in particular, when we have powder that we have been using powder the last years that is made of materials that were used conventionally, for example, titanium 6-4 or Inconel 718. These are materials that were traditionally used in other techniques like forging or casting, like, for example, in case of aluminum, silicon, tin, magnesium. Most of those materials are powder and not made very tailored modifications for AM. So we need more specific materials that are made for AM in order to have better traceability, a more robustness of powder that can withstand all the cycles of the process, of the AM build process, in order to reduce the cost, because now we take into account that the powder is reused. If we don't reuse the powder, the process becomes very costly and also very not very sustainable, because this is one of the most expensive sources, the atomized powder of this powder bed fusion. But I could be talking for hours about this topic.
No, that's interesting. To me, it's very interesting. I find that fascinating. So that's what your research is on, that you're working on reusing the powder, that in the process, that's what you're doing now?
Yeah, I'm concentrated in this area. So that's where I did my PhD, and I'm very keen to continue on the sustainability and studying how to increase sustainability of laser powder bed fusion techniques, not only from the process quality, let's say, point of view, but also material.
Wow, that's fascinating. Yeah, we work with material science, but I can speak for Rachel, Jessica, and I. We have software that addresses that, but we don't work with it down to the molecular level. That's not really what we do, but I find that fascinating. That's interesting that you do that. So yeah. So yeah. So anyway, so I do have one more question before we open it up to the audience to see if we have any questions from them. Just as a fun question, and just, we're talking about the future and where we would like to go, and, Laura, with your sustainability and your vision, which I think is super cool. If you have one crazy future for where you would like to see additive manufacturing, where you think it could be in 20 years, just one wild, crazy vision, where would you like it to be? And Laura, we'll start with you.
Well, one thing is where I want it to be and where I think it will go. I think it will take us some time still, because we have finished the part of exploration techniques from the point of conventional manufacturing. So we have parts that are inside components, inside systems that we're manufacturing conventionally. So we are trying to change the design of those parts, but without thinking on the performance, on the functionality, with having just a mindset of AM. This is, I think, the next level. and there are a lot of new companies, entrepreneurs thinking about completely new products that are AM based. So I think that's one part. And the second is on the sustainability topic, to create also materials and to expand more this technology in that direction, that we can have just an AM focus in terms of material and design. So we don't have this, let's say, restrictions from our mindset of the conventional manufacturing way. And this is, I think, where I also wanted to, that this would go forward.
Okay, all right. Rachel?
Yeah, thanks, Rani. Yeah, so I will preface this by saying, you know, I'm one of these kind of crazy people who, you know, still drives their 13-year-old Honda Fit. So for me, this kind of idea of sustainability isn't, you know, let's make more things. It's really, how do we extend the use of the things that, you know, already exist? And then so, you know, so I also kind of really resonate with this idea of, you know, material circularity that we've seen some talks on. So I feel like, you know, as a culture, we're kind of moving towards this, oh, something breaks, it's easier to kind of throw it out and actually cheaper to just buy a new one on Amazon. You know, one time we had like I think the control panel or something on our stove broke, and it was actually cheaper just to buy a whole new stove. And that's, you know, ridiculous when you think about the amount of material that's, you know, in an appliance. And so what I would really like is for, you know, AM to be kind of this enabler of, you know, an ecosystem or an environment where it's actually easier to, you know, get whatever custom part you need or custom module or, you know, something just to repair what you have, instead of always forcing us to, you know, kind of buy entirely new things. So I think one of the places that, you know, there's a lot of focus now is kind of electronics recycling. So, you know, we're definitely at the point where electronics are cheap and kind of being considered disposable. And so, you know, my hope is, you know, maybe we tackle this challenge of, you know, how do you break down these different components into the different, you know, precious metals and the different plastic constituents. Maybe it gets broken down into some powder-like material that you can sift through, and then, you know, maybe AM is a big part of how you build that back up into new things. And there's your, you know, kind of material circularity. Who knows?
Save the world.
Yeah.
No, it makes sense. And it's funny that you say that, because over the holidays, our oven did break. And that's exactly what and it's not even a year old. And they said, oh, we'll just replace it. And I'm like, it needs a control board. And they're like, well, it's, you know, it's X amount of dollars, I forget, or we'll just get you a new one. It's easier. I'm like, no, just fix the little part that broke. And, you know, we argued with them, and they finally fixed the little part, but they were just like, we'll just give you a whole new one. And I'm like, it's brand new. We barely used it.
Yeah.
So yeah, I agree with you. Could be a good business, but yeah, something to think about. Jessica?
Oh man, the engineer side of me, obviously moving into primary structure, that's definitely an area we haven't got into yet. So we're still crashing our heads with, oh, we have to have that titanium structure and it needs all those bolts to hold it together. So I'm hoping seeing more opportunity there. The innovative side of me, you know, Rachel might be in her little old Honda, but here I am in my Tesla, like, how much can I run off my phone so I don't have to carry a purse? You know, hooking up everything in my life to one device. I've been in meetings all day, so it's like I haven't had time to do anything. Just push that button, 3D print me up some dinner. If I'm flying on the airplane back and forth to the office, I don't like the menu on the plane. Like, print me up some more of those cookies. Like, I don't want to be the last person there where, oh, we've given all the cookies out. Go print me another one. So branching out into not only integrating it into building things, but looking at it across different industries. And, you know, I mean, that's going to be way down the road, but it would be nice not to have to always send my kid to go get my tea.
So when I was manning our table before and you know, staffing it, I don't know how we got on the topic, but I ended up talking about one of the companies that we work with that engineers and additive prints using stem cells body parts. So I was like, well, we could scan your whole body so that, if, you know, gosh forbid, or something, you got into a car accident, it would already have your body parts as your body, right? So if you lost an ear or a broken nose, we wouldn't take a picture of you and say, oh, this is what we think you look like from a 2D scan. We would actually have your 3D scan, and we could actually reverse engineer you, and we could 3D print whatever body part or limb you lost, and it would actually be you. So I think that's my vision for the future. You would 3D print yourself proactively, which is a little morbid, but you would, and then you could actually have yourself printed. And of course, one of the gentlemen that was at the table was like, well, I'm going to 3D print myself now, and then I would just have two of me, and then we could, you know, be more productive. Of course, you know, that's another way to look at things, because then it would have two brains and two people, and you could do your life in, I guess, half the time.
A lot of ethical issues here, Rani.
I know we just go into a lot of different ways, but yeah, but I mean, think about it. There's so many things that you can do for 3D printing. But
there's a movie on that, Multiplicity, I think,
yeah,
the old ones. They all had different personalities.
That's exactly what I said. There was a movie, but the brain got a little not as smart as the multiple bodies got produced. The brain got a little stupider. Not even a word, but yeah. But yeah, so we could keep going and going. But yeah, I like the food idea. I do like the circuit board idea. And of course, I do like sustainability. So I think they're all great ideas. But that was it for as far as the planned questions. I don't know I don't know how this chat actually works. So I don't know if we got any questions in for us.
Yes. Hi, ladies. Thank you again so very much for those just really interesting topics. I loved that last question. That was awesome. But we do have some Q&As here. The number one question that we received all the votes was, what barriers do you all believe exist within the DoD that are limiting AM advancement? If you were queen for a day and could make one change within the DoD to advance AM, what would it be?
Rachel, do you think you could? I think you're the one that probably works with DoD. I don't as much. Do you?
Well, so my view actually of the DoD is different. I feel like they're actually doing quite advanced things for additive. Like, actually, I feel like they are the ones, in terms of at least the simulation technology, they are the ones that are pushing the boundaries. You know, they are the ones who want to have all of this advanced simulation. I need to have a part library of, certified parts, but I want to have that as, build instructions, right? And so, they're the ones who want to have, no spare parts inventory, or be able to have the ability to print spare parts kind of wherever they want. So I don't know. I feel like the vision is pretty good in terms of, technology wise, what they're trying to accomplish with additive. I don't know, Jessica, you probably have some other thoughts in there.
I would say more sharing. I think the DoD has some ideas, but think about like how people are holding that IP. When they do go through the process of the material certification and they get there, they don't want to share it with anyone because they're the first one there. And you have to have a lot of simulation analysis results. And luckily in aerospace, we do have the ASTM international standards and the ISO. So we do have some standardizations, but there's not a lot of just data sharing across the board on that details and the analysis for the type of material that anyone could reuse and kind of grab that and go. Everyone is starting way over here at the beginning, kind of playing with it. So I would like them to kind of drive some sharing and partnerships where more companies can kind of hit the ground running versus having to start from scratch.
Excellent. So another question that we have in the chat is, if you share a model with another location in the world, how do you share the detailed printing settings so that they get the same verified results in different locations?
Yeah, so I mean, I think any of us could take that, but I'll give a crack at it. So so at Dassault System, we're very committed to this idea of the digital thread. And this has come up in a few of these different talks of, the digital thread for additive is difficult because, we're changing the way people design things now. The design is really part of the manufacturing process. All of that is, integrated with the data analytics, process control, simulation. So AM is actually a great playing field for this idea of digital thread. So within our software offering, or within our product, which is our representation of the digital thread, we've kind of the way we are representing build setup is actually kind of similar to the way we represent CAD. So we know CAD is kind of, there's whatever, you have your CAD data within your PLM system, and this is your kind of library, your single source of truth for that design. We have set up our manufacturing planning the same way. So the build setup, which has your print settings and all of build orientation, support structures, laser paths, all of this information is actually also an entity within this digital thread that can be tracked. So then when you are sharing it with somebody else, it's that exact build setup that will be replicated with what they with what they're building. And this is really kind of one of these benefits of the digital thread is, that, instead of, you're not exactly quite sure how suppliers printed your part, it's the exact build instructions kind of encompassed in the file or in the system.
And you can have, to add on to Rachel's point, you can have configured settings specifically for that type of machine in the location. A good example is like Denver versus LA. You have an altitude difference. So you are able to track some of those unique parameters on those individual machines as well to help feed that.
I also wanted to add, apart from the digital thread, it's the repeatability and the machine-to-machine differences. So one of the main advantages of AM is that you don't require highly skilled, or at least, well, not as a traditional or conventional manufacturer. So let's say you can just upload the printing file and the process parameters and print, but how much the external environmental conditions play a role, how much the temperature of your lab or your manufacturing facility. So this is still something that is work in progress to study how much repeatability you can get with different machines and with different procedures, even if it's very well described. But I would say this is a small point of attention for repeatability, especially for certified components.
Our next question is, what is the future of polymer AM in commercial manufacturing?
I mean, I think we already have polymers. One thing I have started to see is utilizing them in a lot of interiors. If you look at the actual work some of our custom interiors make, for example, one of the customers I work, their cabinet process is 12 weeks. It's a huge lead time on them. And you think these are private, they're picked based on customer configuration. So I think if we can figure out a way to incorporate printing maybe some of those different type of polymers, different type of certain properties you want, there could be an opportunity to really expand that across the interiors of the aircraft as well.
Yeah, another place I've seen uptick in this is in kind of like additive ducting, if that makes sense. So I guess it's kind of any type of piping or tubing where you kind of can optimize your internal channels for whatever, flow optimization you want to do. And then you can use additive to build, these really complex channels. So I think that's definitely somewhere that I have seen kind of, polymers for AM starting to pick up in commercial applications.
Good. So how do you recommend getting designers on board with AM and the associated risk?
Make it fun. I guess that's the first thing I think about. The hardest thing you can do, I'm a mechanical engineer, and the hardest thing you can do is go in and say, don't do it the way you've always known, do it this way.
Yeah.
They don't like that. So I've almost seen more people get involved when you turn it into a contest and say, okay, you guys are all in teams. What is something that each team can come up with for a savings or to improve a product? So now you've kind of brought in the competitive side of it and you get more people flowing. So if there are ways to make it fun between the designers and the people coming up with ideas, that's always worked well.
Yeah, that's a good idea. I agree. I think don't make it daunting. It's not. And I think that's usually what is usually the biggest inhibitor, because everybody's like, but I always did it this way. And that's usually the biggest, it's the mindset, it's the change management that has to go through their mind in the process. So I like that, Jess. I think that's a great idea. Make it fun, but I'm on the design side, so I don't struggle with it much, because when they look at the tool and they see the change that can happen and the savings that can be made, or the assembly that can be made smaller, they usually just get excited by saying, I can do that with that many clicks. And you're like, yeah, here. And they do it, and they're like, it makes them want to do it. It's not that daunting. So I think that, coupled with make it fun, is a good idea.
And it's kind of like this idea of like AM is like the design can be specifically for the physics of the part, right? So it doesn't have to consider the manufacturability. So at least, for the simulation side, it's really, you got to tell designers, it's okay. The simulation is not that scary. You don't need to be a simulation person. You can just use the technology, but in the way you're familiar with. I think that's the for me at least, that's the gap that we have to bridge here.
Multidisciplinary teams are the way with AM. You need a little bit of every expertise that you can have: material science, designers, mechanical engineers, process engineers, to have the full process cover, I think.
And I always say start small. That's another thing people don't think about. Like, you don't necessarily have to jump in and tackle a certified part. Like, do shop aids, do things to help out in the factory or with manufacturing. Start small and work your way up to something bigger too.
Excellent. So our last question is actually directed towards Laura, and it says, Laura, which aluminum alloys have you worked with, and are you open to qualifying additional suppliers? Sounds like someone out there wants to be a new vendor of yours, Laura.
No, this is a field where aluminum is also a promising material. I mentioned before, aluminum, silicon, tech, magnesium. This was the most traditional casting alloy. But which material I'm very happy is high strength aluminum, like Scalmalloy. And of course, I would be very happy to discuss for new materials, because there are infinite, and the sky is the limit for AM. So please reach, and we can discuss about possibilities for collaboration.
Very good. Well, thank you all very much for joining us from Dassault Systems. I've learned today how to properly pronounce the name of your company. So thank you all very much for